denominator. Yes? When we add and subtract, common denominator. So if we look at D, what does it have? That common denominator, right? Now, there's a catch with D. See if you do it right. Now, we are subtracting everything behind the subtraction sign, yes? Not just the first term, everything behind. So the common error when people do this question, when I have a binomial or a human behind the minus sign, is that they do not distribute that minus sign through. We're subtracting everything, okay? So when I gave it to you, I want to see if you would do that. So we get 5y minus 1, and then we have to minus the 4y, and we also have to minus the 7. Do you see how that's a common error to forget to minus that 7? Do you think they're going to have the answer to you forgetting to subtract the 7 as well? Do you think they're going to have that error and have you have a plus 7? Yes. So you see how this is a subtraction sign? You can't just subtract the 4. You have to subtract everything behind a subtraction sign, yes? So you have to subtract the 4y and you have to subtract the 7. Now I collect like terms and I use yams and nothings. So I have 5 yams. I subtract 4 yams. How many yams do I currently have? 1 yam. And then I have negative nothings minus 7 nothings. How many nothings do I not have, I guess? 8. Now, can I take this 8 and the 6 and cancel them off? No. The y minus 8 is a what? Human. And the 6 is a what? A snowball. And can snowballs and humans ever cancel? No. So your guys' problem at the end of subtracting and adding is oversimplifying. You're like, cross these off, cross that off, cross over here, do this. Nothing can cross off. She does. This is a y minus 8 and a 6. Do I need those brackets? No. Can you have the brackets though? Sure. Human snowman can't cancel. Oh, example 2 is where life starts getting real. Real awesome. That's what I say. Real awesome. We have a 4 and a 3, people. 4 and a 3. Are those common bases? All together now. No, they are not. How can I make them common bases? What number can I make them both be? And remember, when you make a common base, it's by multiplication only. So I can make them both be 12. That is true. So my first step is always common base. It was already done for us on the previous ones, which was sweet. It's not anymore. So I have 3x minus 4, and I want to make the denominator be 12. So I'm going to multiply it by 3. Can I just multiply a denominator by 3 and say that it's the same? I just multiply a denominator by 3? No. I have to also multiply the numerator by 3. Remember I showed that in the pizza? When we split the 3 pieces into 6 pieces, you ended up getting the top was multiplied by 2 and the bottom was multiplied by 2. You have to do both, okay? Then a minus sign, and then we have x over 3. And we have to multiply this one by 4. And when we do the bottom, we have to do the top. 4. So we're going to get 9x over 12 minus 4x over 12. Now, are we not in the same boat that the previous questions were in right now? We're actually where the other question started, right? Common denominator. That's all we've done so far. We've done nothing extra other than we've made made them like the previous questions with common denominators. So now once we have a common denominator, we can write them all over 12. And then we do 9x minus 4x. And we're going to treat them like xylophones so we don't mess it up. So I go 9 xylophones minus 4 xylophones gives me 5 xylophones. So 5x, right? If you treat it like xylophones, you will not make a mistake. Now the 5 and the x is a snowball. The 12 is a snowball. So if I could cancel something off, I would. Can I cancel anything off? No. Are there any NPVs? Is there any variables in my denominator? No. I'm done. Okay, you guys try B. Hint, what common denominator can we make them both be? We can make them be 6, correct? So I don't actually have to touch the right one at all. The left one, I just have to multiply the bottom and top by 2. Go. So with multiplying, dividing, and simplifying, our first step is humans and snowballs. And if I have humans, GCF, difference of squares, all of them, cancel stuff off, right? So addition and subtraction, my very first step is what? Every single time? Common denominator. So for this one, okay, I threw the line, but nothing happened. For this one, I'm going to take the 3, and look guys, we're going to have 3a minus 1 over 3 plus 4a plus 5 over 6. And then I'm going to multiply this one by 2. I put the 2 in the front if I really want, or 2 in the back, doesn't matter. Now, you should have equal signs running down your page because every expression equals the next expression equals the next expression equals the next expression, okay? You shouldn't just have random things floating on a page and no equal sign to be found, okay? So always check. So we have 2 times 3a is 6a, and then we have 2 times negative 1 is negative 2, over 6, plus 4a plus 5 over 6. Now what you're going to have to stop yourself from doing is what some people do is they'll make a common denominator and then they're like, oh, I can take a 2 out, and they cross back off. And I'm like, no, you just put the 2 on. You're just back to where you... So once you get a common denominator, in adding and subtracting, our first step is common denominator. Then write it all over one denominator, right? That's the next step. So we're going to get 6a minus 2 plus 4a plus 5. So what do we get? We get a common denominator. Then we write everything over the denominator. Now we collect like items. I know it's like terms, but because I call them items, they're items to me, right? Then I don't mess up the letters. So I have 6 apples. I always say apples. I was going to try and come up with something new, but I'm not that original. 6 airplanes. Oh, I like the airplanes. That's a good one. 6 airplanes plus 4 airplanes gets me 10 airplanes. And then minus 2 nothings plus 5 nothings gets me 3 nothings. And if you want to, you can connect it and say, oh, that's a human. And then on the bottom I have a 6. Oh, that's a snowball. Now you can say to yourself, can I go any further if I have a human in the numerator and a snowball in the bottom? Can ever a human and a snowball cross each other off? No, you're done. Are there any NPVs? No. Do I need the brackets? No. Can I keep the brackets? Yes. But the multiple choice answer will look like this, just to not throw you off. It won't have the brackets. But having the brackets in a written response will not make you lose marks. And it is a way to realize that it's a human and a snowball. So it doesn't matter. This one or this answer equally is good. Okay, you can't be deducted. I just wanted to show you that they won't have the brackets. Okay? Okay, guys, what's common between 8 and 3? 24. That's about it. Okay? So we're going to have to multiply each other by each other. I'm just going to cross that. It's page 11. I just don't want it to get in my way. So I have 8y minus 3 over 8 minus 2y plus 1 over 3. It's, okay, it's adding or subtracting. Oh, it's subtracting. My first step is what in subtracting? Common denominator every time. Okay? So this one I'm going to multiply by what? 3. And this one I'm going to multiply by what? 8. Try it out. Go. On the top, I have 24y minus 9 over 24 with an equal sign running down the left-hand side because this equals this, right? We got it. Then we're going to have minus 16y plus 8 over 24. Okay. Then we're going to have, we have a common denominator now. First step. Second step, write it all over that denominator. What do you have to watch when it's a subtraction sign between, guys? That you put it through, that you subtract everything behind it, right? If you're someone who didn't do that again, you're going to be someone who that's going to be a problem for. So highlight, highlight, highlight. So we're going to get 24y minus 9 minus 16y minus 8. Okay, Lord, what is going on? Go away. Minus 8. Okay, so our first step, common denominator. Our second step, write it over the one denominator. Our third step is collect items. So now I have 24 yo-yos. Minus 16 yo-yos is 8 yo-yos. Negative 9 nothings minus 8 more nothings is negative 17 nothings. This, my friends, is a human. We agree? This, my friends, is a what? Snowball. Can I cross that 8 and that 24 off? Do you think they're going to have the answer to someone screwing that up and going y minus 17 over 3? They absolutely will. It would be number one common error after the error of not remembering to put the minus sign through. So every error that you will make will be there. So you need to know your stuff fully or you will pick the oopsie. And it'll be there and you'll be like, oh, my answer's there, and you pick it. Okay? So there's always one correct answer, 3 common oopsies for every multiple choice. So you need to know your stuff. Friends, between example 3 and example 1, because example 3 is common denominators. What's the difference between example 3 and example 1 on the previous page that we did yesterday? Yeah, it has variables in the denominator, so what am I going to have to state? MPVs and restrictions. That's the only difference between example 1 and example 3. Okay, try these out. So for this one, we have 2 over x plus 7 over x minus 1 over x. It is addition and subtraction. I need common denominators. Done. Cool. Great. Good discussion. Then when I have common denominators, I write it all over one denominator. 2 plus 7 minus 1. So I have 2 nothings plus 7 nothings minus 1 nothing is 8 nothings. I say nothing because there's no variable in it. Over x. Snowball over snowball. Can I cancel anything though? No. What do I have to remember to still do? NPVs. X can't equal 0. Can I do the NPVs at the end? I technically can. The only way I can't do my NPVs is if I do NPVs after I cancel. So if the whole way through I haven't crossed anything off, I could technically do my NPVs at the end and I'd be fine. You just have to state your NPVs before you cancel. If you're like, oh, this could cancel off this, slap your hand like, no canceling until my NPVs are done. Okay, B. I have over 2a over 2a. First step, common denominator. Check. Second step, right over one denominator. So I'm going to get a 2a in the denominator, and then I get a 5a plus 3, and then I'm just adding so it doesn't affect anything, plus a minus 6. And then I treat it like they are items, right? So that I don't screw up. Items, items, items. Now you're all like, that's stupid. It will stop you from swearing. You guys will swear. You guys will cube. It will happen. You're like, no, we won't. Yes, you will. I've watched it. Remember? 18 years of doing this. I literally know what you're going to do. I know where the common errors are going to happen. I know what you're going to oopsie on. I know what you're like, no. I know in your head you're like, no, let that never happen. I know that's all happening because this is my life for so many years. Guys, almost half my life. Oh,
It's our entire lives.
it's your entire lives?
Yes.
Over half of mine. Under half of mine. Almost half of mine. It's getting close. Did you just say 50? Did you just say 50 in your head? That's what I saw, Harvey. Okay. You said at least 32. That's what you said. Yeah, I know. That's what I am. Yeah, I'm totally 32. I'm going to go with it. And you're all going to buy it. And then you're going to buy what I'm selling. Started teaching in 2006 and I'm only 32. The mathematics right there is great.
How many years for being employed?
I started teaching a week before I turned 23. So I'm obviously 32. Mathematically, that's how that works. Her brain isn't braining. 18. Are you doing 24 subtract 6? So confusing. What is she doing? I didn't give any of those numbers. None of those numbers existed, Claire. What are you doing? 24 minus 6? What's she doing?
41.
I'm 40.
Oh, right, a week, 2:30.
My birthday's in September. I'm knocking at 41's door, but you know. Now I'm 32. That's what I am. I'm sticking with it.
I would say 32.
Yeah, thanks.
Like,
Harvey was going.
I was not expecting you to say that.
So we have 5 anteaters plus 1 anteater is 6 anteaters. And then 3 nothings minus 6 nothings is minus 3 nothings. Now, if I could take something out of the human, do I take something out of a human? No. If I could take something out, like physically GCF, I haven't been able to yet. Yeah. Remember humans, you can GCF for difference of squares, these are snowballs, right? So I could take a 3 out of the top, it would become a snowball. 6a divided by 3 is 2a minus 1. I'd have a snowball here now. And then a 2 and an 8. So at the very last step, you can do that. Now some people are like, oh, 2a, cancel off. Can we do that? No. They're not stupid, they're going to do that. So they are just going to make an oopsie. They're oopsiators. Okay, don't oopsie. If you use the brackets and say human and snowball, you will not make mistakes. I promise. I know it's stupid, but you will not make mistakes. Because this is a human. 2a minus 1 is a human. We see that? How do I only cancel off humans? Another human. Is there a 2a minus 1 in the bottom? No, so can they cancel off? Nah. What about the 3 and the 2? They're snowballs, but is anything common to them? No. Is there an a or an a squared by itself? No. So we're as good as we get. And then we follow behind with a can't equal 0. The people who don't bracket and don't think humans and snowballs will cancel wrong things off. Okay? Don't be those people. Okay, this one we have 3y minus 1, 3y minus 1. We have a common denominator of 3y minus 1. And then we can put the top together. 3y minus, ooh. And then I see human, cancel, I'm going to cancel. And then I'm like, girl, please. You must do something else first. Bless you. Guten Tag. NPV is what you said. Exactly. So we have to do 3y minus 1 can't equal 0. Add the 1. Add the 1. 3y can't equal 1. If you're like, I don't know how she does NPVs, remember I told you get past denial, get right to acceptance, and start asking questions, please. Okay. Cancely, and then it's 0, obviously. Or what are these slanted lines just? Ones. They're just ones, right? So we're left with 1. Y can't equal a third. Pardon? Fraction, I don't know. I know like moins is minus and plus is plus and fond is equal, but I've got no French on fractions. Took 7 years. I have very little left. It's been a tick. All right, let's look at this one. X plus 3, x plus 3, x plus 3 in the denominator. Then we have 4x plus 10 minus 2x plus 4, obvi. En français, non. Non. Negative. Negative. So, what I didn't do is a common error, right? I have to subtract the 2x and I have to subtract the 4. And so I get this. So now I'm going to do 4, that's a eraser. Oh boy. Okay, come on. Okay, come on. Why is it not? Oh gosh, I hit the plus sign. I'm a wreck. I'm a wreck. I don't even know what's going on. Where the heck did I go? Oh, here we are. Okay, whatever. I'm just gonna write it back out. 4x plus 10. Okay. What? How did I cut off those? Okay. 4 xylophones minus 2 xylophones is 2 xylophones. 10 nothings minus 4 nothings is plus 6 nothings over x plus 3. Then obvi I'm done. No. What can I do? I can take out a 2, because I can look at the humans at the end and say, oh, I can take out a 2. Then I'm left with x plus 3. Oh! And an x plus 3. Oh! And I can cancel them up. And I'm like, no. NPV. NP. So x can't equal negative what? Done. 2. Oh, 2. I know font is equal. X, no font. Negative 3. All right. What's the problem here, friends? We don't have common denominators. And there's some variables in there. Yeah? Okay. If you look at all the denominators here, they're all snowballs. Yes? Can you make a snowball be a snowball? Oui. Yes. Si. Really switching languages. Okay. So we technically have 5 over 3 and p plus 2 over 7 and p. We agree? Because they're each snowballs, yes? So what do each of them have in common currently? The variable, the p. So do I actually have to do anything to get the variable to be the same? No, I just need to make the numbers the same. So what can I make 3 and 7 be? 21. So I can multiply this one by 7 and this one by 3. And I'm going to get 35. And when it's snowballs, you can put them all together. When it's humans, you can't. But when it's snowballs, you put them all together. So I get 21p plus 6 over 21p. Now, how do you know you messed up? Well, you look and your denominators don't match, right? You mess up if you don't have a common denominator. So then you try again. But I do have a common denominator, so now I'm where I was in the previous question. Write it all over one denominator. And then I get 35 plus 6. What's 35 nothings plus 6 nothings? 41 nothings over 21 and p. Remember, the 21 and p can be in brackets or not in brackets. So I can bracket the crap out of this whole thing if I really want to, right? Or no brackets, because it would still work. If they're all snowballs, you don't need brackets. Am I done? No. What? NPVs. So I have 41 over 21p. And if I have a p by itself, what's my NPV? P can't equal 0. 21 and 41. 41 is a prime number. So no. But if you could, you would. If you could take like a 3 or a 2 or something out, you would. Okay, go. Try the next BCD. We have 1 over 3 and y plus 6 over 5. Now I need to make my denominators the same. So 3 and 5, I can multiply them to make them both be what? 15. And then this one I need to also get a y, correct? So this one I'm going to multiply by 5. This one I'm going to multiply by 3y. Like I said, you know you didn't mess up if in the next step you have common denominators. If you don't, you made an oopsie. So in the top, I'm going to get 15, and when they're all snowballs, I can put them together. 3 times y times 5 is 15y. Now some people will try and cancel those off. Is that a good thing to cancel those off?
Oh.
I have no idea. I put a 1 and a 5, and then instead of multiplying them, I wrote it as 15. It's a gift. I don't know how to do sometimes I scare myself. It's totally fine. 5. So do you see how it is something when you see that you really want to just cross them back off because you're like, common things, but then you're just back to where you were, and then you just have to do it again, and then you cross off and you're back where you were, and you'll never have common denominator. So remember the steps and stick to the steps. So when adding and subtracting rationals, common denominator, right over one denominator, put them together, right? Common denominator, right over one denominator, put them together. Stop yourself from canceling off what you just made common, okay? And then plus 18y over 15y. And then people are like, oh my goodness, I can cross a 3 and a y off. No, you just put them on, right? Do you see how it's like you can actually take them back off because you're so used to simplifying? So first step in adding and subtracting, common denominator. Second step, right over one denominator. Follow your steps sequentially and you won't make oopsies. So I have a common denominator. My next step is right over one denominator. So So I get 5 plus 18y. Third step is get put together items. They're already together. Now I have 5 plus 18y and 15y. Can I do anything? Can I GCF or difference of squares the numerator, which is a human? No. So I have a human on the top, 15 plus 8y. Do I have a matching twin on the bottom? No, so they're going nowhere. And the denominators are both snowballs. Do I have snowballs in the numerator? No. So I can't do anything. You have to stop yourselves. A lot of you guys are going to try in the 5 and 15, the y and the y, and you'll have some random thing like 3. Okay, don't do that. And then we have behind it, y can't equal 0. Okay, here we have 6x and 3x. So we have 2x minus 5 over 6x, 6 and an x being both snowballs, minus 3x minus 2 over 3x, the 3 and the x being snowballs. So they both have an x snowball, yes? What do we, so the x's are done. Cool, match, match. Yay. Okay, then we have a 6 and a 3. What can we make them both be? Yeah, 6. We'll just times this right one by 2. So we'll times this by 2, times this by 2. But you have to remember to do the whole top, right? So we're trying to make a common denominator here. So I get 2x minus 5 over 6x minus 6x minus 4 over 6x. Step 1 done. Common denominator, correct? Step 1, common denominator. Step 2, right over 1 denominator. Yes? Do you see the steps never change for me? Step 1, common denominator. Step 2, right over 1 denominator. So I'm going to get 2x minus 5 minus 6x plus 4. Because minus a minus 4 makes a plus 4. So first step, common denominator. Second step, right over 1 denominator. Third step, collect items. I'm never changing my steps. It's never changed the whole time with that subtracting. So collecting my items. 2 xylophones minus 6 xylophones is negative 4 xylophones. Negative 5 nothings plus 4 nothings minus 1 nothing over 6x. The top is a human. The bottom are snowballs. Is there any way they can cancel each other off? Can I GCF anything out of the human? Difference of squares the human. Nothing to the human. So I'm done, right? Nothing can cancel. And what do I follow behind with? X can't equal 0. When your denominator is all snowballs, it'll be x can't equal 0. Okay, here we have a plus 7 over 2a squared minus 3 over 5a. Okay, let's just look at the variables first. The left denominator, the left bottom, has an a squared. The right bottom has an a. So the right one's missing an a. We agree? So we're going to have to multiply by an a of some sort. The right has a 2. The left has a 5. What common number can I make them both be? 10. So I'm going to multiply this one by 5. And this one by 2a. Correct? It needs an a and it needs a 2. So we are going to get 5a plus 35 all over 10a squared minus 6a over 10a squared. So first step, common denominator. Check. Second step, right over 1 denominator. Five a plus 35 minus 6. Third step, collect items. 5 apples, and that's it, so I have 5 apples. 35 nothings minus 6 nothings is 29 nothings over 10a squared. Oh, so disappointing. It is. Look at the copying that happened there. It didn't. That's what happened. 5 apples minus 6 apples is negative 1 apple plus 35. This is a human. Can I take anything out of this? I could take out a negative 1, but would it change anything? No. The denominator is a what? Snowball. Can I do anything to those? No. So I have an a squared snowball. So what's my NPV? A cannot equal 0. Okay, so you're going to grab the textbook, and I'll take pictures of it if you need to. I'll post it into Google Classroom for the homework. You're going to do, this is the textbook, the hardcover thing. It has a whole bunch of, it looks like a kite, but it's a whole bunch of people skydiving. Page 249, numbers 3 and 4. I want you to do that first, because that is actually the addition and subtraction which we just practiced. And then I want you to do page 265. These shouldn't be hard. Number 3 is all common denominators. Number 4 is like what we just did. So they're not crazy. 265, I want you to do number 3 and 4. I will let you guys grab the textbooks, but I will also post pictures of them with the answer key in the assignment on Google Classroom right now.